Hello, and thanks for joining my presentation about what is Ansible and managing PostgreSQL with Ansible. The agenda we have for today is first to show you what is PostgreSQL. I think we can skip that. You should all know what it is. And then an introduction, what is Ansible? Just a quick intro. I will show you how you can run ad hoc commands using Ansible. I will show you how you can write and use playbooks to manage all of your hosts and databases. And then I will give you an example how you can install a PostgreSQL database and run arbitrary queries on it. Let's dive in. So my name is Andreas Scherbam. I work with PostgreSQL since 25 years, mostly. I am one of the board of directors for PostgreSQL Europe. And we did organize conferences like PGConf EU, PGConf DE, FOSDEM PG, etc. Since September this year, I work for a company called Adjust in Berlin in Germany. If you want to follow me on my Twitter, I have my handle here and also my link to my blog. I think I can skip introducing you to PostgreSQL. We all should know this. And on this conference and many other conferences, we have enough talks about PostgreSQL itself. So let's skip to Ansible. What is Ansible? It's a device for superluminal communication, which was first invented in a 1966 novel by Ursula Le Guin. And most prominently, it was used in a movie called Ender's Game. It's probably not what we're looking for, so we're looking for something different. Ansible is an open source software for provisioning and configuration management. You can run Ansible on any Unix-like host as a controller, and Ansible can manage any Unix and Microsoft Windows hosts. It's under development since 2012, so about 8-9 years now. And in 2015, Red Hat acquired it, and it's still open source, which is good. The current stable version of Ansible is 2.10. It's nice if you have some Python knowledge, but it's not really required. But at many points in the configuration, you will see that it really leans on Python and its syntax. What are the advantages of using Ansible? So first of all, if you use Ansible playbooks, your code and your playbooks is kind of your documentation. So you document what you're installing, you document what you're changing, and by rerunning all of your playbooks, which you can do anytime, you have confidence that your automation really works. Ansible introduces a concept called idempotence. You can rerun any playbook you have at any time, and it will only change your host and your systems if a change is necessary, whatever you defined in your playbooks. You can run playbooks for multiple locations, so any of your developers can have its own playbook and run them at any given time. All you have to do is make sure that anyone runs the same playbook and not different playbooks. So there's no agent you have to install on any of the hosts you want to manage. These days, Ansible requires Python version 3. Version 2 is no longer supported. For some of the modules you're using in Ansible, like for the Postgres modules, there's a need for install additional Python modules on your host. Most importantly, if you want to manage PostgreSQL, you need to have a Psycop module installed as well. So how does Ansible work? You have your own host, your laptop, your workstation, which is the Ansible controller, and the Ansible software runs on this host. Then Ansible is using SSH to connect to the other hosts you want to manage and is executing commands on this host. It does so by temporarily deploying Python scripts on the other host and executing them. And once the job is done, it's removing the hosts again. So there's no permanent installation of any software on the remote host. Ansible has a couple hundred modules to install all kinds of software and hardware. So for databases, any open source database you find out there, like Postgres, Mongo, MySQL, InfluxDB, and so on, is supported by modules. Many kinds of network equipment and storage equipment, etc. are supported. So I don't want to go into this list here. If you check a documentation on the Ansible website, it's a very long list you can find there. For today, we want to look into how we can manage PostgreSQL on using Ansible. So out of the 4 hosts we have here, the web servers and load balancing, etc., we're only looking at the PostgreSQL host. If we look at the PostgreSQL modules we have in Ansible, so we have modules for creating and deleting databases, installing backups, creating roles, memberships, ownerships, extensions, privileges. We can even set up replication slots, etc., all using Ansible. We can use the basic tools we have in Ansible to manage access control using PGHBA, and we can also run queries against the database. Keep in mind, many of the modules we are talking here only started to appear in Ansible version 2.8, so it's 2 stable versions back. If you have an older version installed, it's time for an upgrade. Ansible has 2 different concepts. One is called Ansible ad hoc, where you run any ad hoc command on your remote host, and the other one is called playbooks. Let's look at ad hoc first. With an ad hoc command, you can run any arbitrary command on your remote host or remote host groups. And in my example here, we're going to just ping the remote host, see if it's alive, and if Ansible can log in. For this, we need the Ansible command. We need to specify the hosts or host list we want to have. That's by specifying the inventory here. And the inventory is a Python host list, so you always have to close it with a comma. Then we specify the module name we want to use. In this case, it's called ping. And we specify which host or hosts we want to reach. In this case, if you specify all, then all the lists we have in the host list here will be pinged. So once we execute this, we get a success message back, obviously only if Ansible can log in. This is not the network TCP ping command you're using usually to reach out to remote hosts. The Ansible ping is logging in on the remote host, and it's checking if Ansible has all the credentials to actually log in a host and execute commands. So for this, Ansible needs to be able to log in without specifying a password. Think about it. You have a couple dozen hosts and you have login with passwords, and every time you want to log in and you want to run a command on all hosts, you have to specify the password for each and every host. You really don't want to do this. And you also need to have a method for executing commands as root. So it's either sudo or su, and this also needs to be passwordless for the user you're using to log in into the remote host. You can use other modules we have in Ansible, and you can specify parameters. The ping module we use doesn't have any parameters, but here I'm executing a shell command on the remote host. It's just uptime for demonstration purposes. And I'm using the command module, and my parameter for command is the uptime command. And then Ansible is executing the uptime command on the remote host, and you can see it tells us the command output here. So this host I used here is up for 5 days, 16 logins, and a load of about 2. Most importantly, it also tells us the return code of the command. Anytime return code is 0, it's fine. If there's an error, it will tell you that the return code is greater than 0, and you have to act on it. The other concept we have here is the changed. So anytime we use one of the Ansible modules, it will tell us if something on your remote host was changed by running this command. Obviously, by running shell scripts or shell commands on your remote host, Ansible doesn't really know what the module is doing. So it's always telling you something was changed, even though uptime command doesn't really change anything on your remote host. Ansible fetch standard error and standard out and the return code from your remote host. It will not show you standard error if there's nothing in standard error, but it will show you standard out and will always show you the return code. This is only of interest if you run in ad hoc mode, because this is when you execute one command on all of your hosts in remote, you are really interested in what is the output of this command. Later on in playbooks, we will see that the standard out and standard error is not really of interest here. About the return code we have, if you have playbooks running, you can actually ignore errors. You can say ignore errors is true in your playbook, or you can specify different conditions when your playbook will fail. So you can have a command which is also returning a different return code than 0, and it's still an error, and you can specify failed when. What is the condition when your command is failing? And as mentioned before, every time Ansible changes something on your remote host, it will tell you that something changed. You can ignore this by using changed when in your playbooks. A couple notes about the commands we can execute. So Ansible has two different commands for executing something on your remote host. One is called command and one is called shell. If you use commands, there's really no variable replacement. There's no redirect for file handles, no nothing. Under the hood, it's using the Unix exec command. So you can only have one single command, and this one is executed in a return code, and output is returned to the controlling host. The other module we have is a shell command. So you can have variable replacement here, you can pipe multiple commands together, etc. But obviously, the other problem you have, if something is in your variables or in your environment, this might change the way your program is executed. Both modules by default will return that the remote system is changed. For the shell commands and the command module we have, if there's a module in Ansible which can replace what you're doing with command and shell, always aim for using one of the Ansible modules. The reason for this is the modules will give you idempotence. So if you rerun your module over and over again, then it will only change something when a change is required. If you use shell or command module, it will always be marked as changed, and you don't really know if something on your remote host was changed or not. Okay, let's move from Ansible ad hoc commands to Ansible playbooks. A playbook in Ansible is really just a text file in YAML format, and you specify one or multiple tasks. You can run a playbook over and over again, and it's idempotent, or if you made it idempotent, it's made idempotent. And this means it will only change something if a change is required on your host. Playbooks can become very large, couple hundred or couple thousand plays in it. So you should really split up them into different what's called roles, but this is not topic of this talk. You can specify that one playbook should only run on specified hosts, like only on database hosts, or you can say they should run on any host. The way you specify this is there's a file called hosts.config in your playbook directory. And in this file, you specify all the target hosts you have to manage. Here you can also specify variables per hosts or per host groups or global. So let's look at an example of host config. So we have two different groups here in a group called all systems. One is web servers and one is databases. We can specify variables which are valid for all hosts globally. But of course, later down in one of the groups, you can override the variables. Then we have our database group here with one host in it and one variable specified as host name. And we have an extra section for variables for the databases group, where we specify that we want to have a DB type PostgreSQL here. The playbooks we have specify task groups, that's so-called plays. And they always are grouped together by hosts. And you always run all the plays for one group by specifying on which host group you want to run them. This is an example of a playbook which is only run on the databases group. So we have a JSON marker up here in the beginning of the file. And we specify this is a host group, this playbook is to be run on. And then we have tasks. In this case, we have two different tasks. So we have specified names, which Ansible only uses to output what we are doing. And then we have two different commands, uptime and uname here. And once we are running this, you see the tool changed from Ansible to Ansible playbook. And the inventory changed from specifying a host list to specifying our hosts.conf. And then we're specifying a playbook we want to run here. As you can see, Ansible goes over the host list. It does a step which is called gathering facts about the remote hosts. Then it executes the two tasks we have. So uptime and uname. So we have only one host, which means we get a result back from one host here. And what you can see, it only tells us something changed here, but we no longer see the output of the uptime command. As I mentioned before, if you run ad hoc commands on Ansible, it's really about you want to see what's going on and what's executed on your remote host. And if you run playbooks on remote hosts, you no longer care about what exactly one command is doing. You only care that it's executed properly. And in the end, we have a summary. So we have two changes here, two tasks changed something, and it took 1 second to run all of this. You can have error handling in playbooks, and you should really look into this. So one of the most commonly used is that you specify any errors fatal, set to true, which means at any point down in your playbook, if you have an error, the entire playbook will be aborted. If you don't specify this and you run your playbook on multiple hosts, then Ansible will only stop running this playbook on any host where there's an error, and it will continue running this on all the other hosts in your list. This might or might not be a good thing. So in this case, I'm specifying a command downtime here, which is really not existing on my remote host. And as you can see, now Ansible pops up a red error message. Okay, there's a problem. There's a return code of 2, so this command doesn't exist. And it stops right here. So it tells me no more hosts to go. Again, if you have this any errors fatal here, it will stop right there for all hosts. If I have like 5 hosts running here and one has an error, then the other 4 will still continue to run. Okay, let's put all of this together and finally go and install Postgres on a host. So we will install Postgres. We will check if we can connect to the Postgres database. We will create a new role in a new database. We will modify pghpa.conf, create a table, plus an index, and finally we run a query. All of it using Ansible modules. So let's start by installing the database. If you want to do this on a command line, you say, in my example, it's Debian apt-get install PostgreSQL 13, and Debian will install it for you. If we use this in Ansible, we have the apt module. So as an ad hoc command, you can specify we want to run this command as root. So this is become parameter here for Ansible. We are specifying the apt module, and as parameter, we specify which packages we want to install, and we specify the state of the package. Once we run this, we see, okay, something changed on a host. This was installed, but there's no error. That's fine. If we want to put all of this into a playbook, we specify our host lists. We specify become. It's a new setting here, which was not there before. Become says this is to be executed as root. And then we have the Debian package module apt. We specify the 3 packages we want to have here. So it's PostgreSQL. And later on, if we want to manage Postgres using Ansible, we need the psycop module. And if you run this using the Ansible playbook, you see it tells us, okay, something changed. Everything is installed, no errors. That's good. If we rerun this playbook again, you see there's no change at all. Ansible tries the same steps. It figures out, okay, everything is already installed. There's nothing to change on a host, and we are good to go. Many of the Ansible modules you will encounter have a state parameter. This usually, but not always, defaults to present, which means if this is installed or if this is available, everything is good. For the app module, you can also use latest as the state. If you have latest and not present, and there's a newer package version available, then Ansible will upgrade the package for you. And if you say absent, then it will uninstall the package. Now that we have a Postgres database installed, let's see if we can connect to it. What we need is the PostgreSQL ping module. We need login credentials, and we need to put all of this into our playbook. Keep in mind, the controller is running this playbook, but the controller is logging in on the remote database host, and the module is executed on the remote host, which means we have to act like we are running on localhost because we're trying this on the remote host. So in this case, localhost is 127.0.0.1, and we're using the remote Unix domain socket. So we're using the PostgreSQL ping module here. We specify Postgres as the default database. We're specifying the Postgres user here. And then we have a new setting, which is we not only use become yes, we also say become user Postgres. So Ansible will go from becoming root to become user Postgres, because on Debian, only the Postgres user can log in into the database without any password. So once we run this, we see tells us, okay, ping Postgres, everything is okay, nothing has changed. So this is just really trying out and figuring out if we can connect to the database. Once we have this working, let's create a role in a database. For creating roles, we have the PostgreSQL user module, and for managing databases, we have the PostgreSQL DB module. Let's create a role, and here we have something new. We specify the username and the password in Ansible variables. So we don't write this down into our playbook, but this is in variables, and we can use a separate file or a vault, which is also available in Ansible, to store this sensitive data. So you don't have to commit a playbook into a Git repository, as example, with all the credentials in it. So we have this variable transmitted in clear text from a controller host to the remote host. But if there's an error and Ansible needs to dump all the information, then it will prevent logging the clear text password to the terminal. You can also use more sophisticated login methods like Scram, but this is not part of this talk. We can also remove a role by specifying status absent, and then Ansible will remove this role if it's present. Like we created a role, we can also create a database. We're using the PostgreSQL DB module here. We have to specify login credentials, and then we specify what's the new name of the database we want to have. Again, it's specified in Ansible variables. And we can also optionally specify what's the new owner of the database if you want this. Of course, if you don't specify the owner here, you can later use the PostgreSQL DB module and change the owner in a later step. The DB module has two additional states we can use. One is called dump. If you use this, it will take a backup of the database you specify. And one is called restore. If you use this and specify a target name, then Ansible can restore a database from your target file. Under the hood, it's using pgdump and pgrestore to do this. Okay, now we have a database running. We have a database created. We need access to the database. In PostgreSQL, this happens by changing the pghba.conf. And in the Debian system, this file lives in root, so we have to have root access. There's a way to use the PostgreSQL HBA module in Ansible, but it's a bit complicated because it only allows you to add new lines to it. There's no way to specify a specific order of lines in pghba.conf, at least as of now. There are two other modules in Ansible, which are called line_in_file and block_in_file, which can do this for you. Or you can also roll out your own template of pghba.conf using the template module. As mentioned before, this file lives in etc PostgreSQL, at least in Debian. So you need to be root to change this file. And there's a new setting here. We have something which is called notify. Anytime one of the Ansible modules changes something and you have your notify specified, then Ansible at the end of the playbook is running the handler here. In this case, the handler is called reload PostgreSQL, but it's not doing this right away. It's doing this once you end the playbook. Handlers are specified in the same way you specify tasks. So you have a handler section, and there's a free-form name for it. That's the same name you used before in the notify. And then you can use any Ansible module here to do whatever you have to do to execute the handler. In this case, I'm using the service module to reload the database. So handlers can be called from many places. You can have basically every task calling for a handler, but they're only executed at the end, so they are queued up. This is kind of useful because otherwise you have to check every single task. If it changed something, then you have to have a handler. By just using notify, it makes it really, really easy for Ansible to handle all of the tasks you have to do or restart tasks you have to do. Okay, let's say we added this to our pghba.conf. So we have demodb demo user with MD5 authentication here. Now we want to create a table in our database and an index. So we have the PostgreSQL table command and the index command. And in the same way we created database before and users before, you specify a table name here, in which database it lives and in which schema it lives. And you can specify all the columns and data types here. This is the table definition you want to create. There's a small problem with the module as of now. It only creates a table, but later on, if you change the definition in your playbook, it will not change the table. So you have to have it right in the first try. Maybe they will change the module in a later step, but as of now, it doesn't do this. You can also use this module to create unlock tables or truncate tables or rename tables. This is all working. You can also specify storage parameters, etc. In the same way we created a table, we can also create an index on a table. So we specify the column or columns we want to have, a table name, and we have to specify an index name here. So in Postgres, if you create an index, Postgres can pick an index name for you. In Ansible, you have to specify an index name here. Okay, now we have our table created and index created on it. It's basically all we need, except we haven't queried the table. So let's run a query on it. That's the PostgreSQL query module. So we can run an insert here, and we can use the PostgreSQL query module to run a free-form query, any kind of query in our database. In this case here, I just insert a value into the table I just created. It can be any select query, insert query, basically every query you can run in a Postgres database. Keep in mind, this is not opening a transaction for you. So if you want to have a long-running transaction in your database, you need to start a transaction before. Instead of the query, you can also specify a file with a script, which will then be executed for you. Each one of PostgreSQL query will be marked as changed, even though you might only have a select query, because Ansible doesn't really know what you're executing here. It doesn't really know if the database has changed or not. We have a new feature of Ansible here, which is called register. All the output you have of this specific command will be registered in the variable you specify here, and you can access this later on. So in my example here, I just want to see the result of the count. So I have my result variable here, my query result. I want to look at the first row of the result, and I specified my column name as count. I have 8 rows in my variable, in my table here. That's easy. Good. Now we have all of this running, we can access and manage PostgreSQL databases. How can we make this even more automated? You can run playbooks from any Linux or Unix computer, and any developer can run them, which makes it kind of easy to roll out because anyone changing something can also roll it out. There's a tool called Ansible Tower, which is a central place to run playbooks, and you can use triggers like webhooks or git commits to trigger something in Ansible Tower. You can also schedule certain tasks, like every night I want to deploy something, every night I want to take a backup using Ansible. Ansible Tower is a commercial product by Red Hat. That's a screenshot how it looks like. And there's also an open source version of this. It's called AWX. This is basically the development version of Ansible Tower. And once in a while, Ansible takes a snapshot from it and creates a new version of Ansible Tower. There's no support from Red Hat for AWX, but other companies might support you using this. And you cannot upgrade from AWX to Tower or vice versa. Okay. So we learned about Ansible and how we can manage large clusters of servers, how we can install and manage softwares, virtual services, applications, etc. It's kind of self-documenting because everything you have running is what you need to document what's changing on your host. And if you do it right, all of your playbooks are idempotent, and you can just rerun them over and over again until you have a successful run. There are many useful modules for managing PostgreSQL with Ansible. We've seen some of them, there are more. And even though it's a bit more overhead to actually create a playbook in the beginning instead of just running a shell script, doing this right from the beginning makes it actually more easy to manage PostgreSQL using an automation tool like Ansible. Thank you. Any questions?